When you talk about the server platform that you're going to want to use to run your vSphere environment on, of course, you're going to want to use supported hardware. There's a lot of hardware that may be able to run ESXi if you want to use it in a test lab or in a non-production environment or a small business production environment. You really should be looking for supported hardware. The list of compatible hardware is quite a bit larger than it used to be, but it's still going to be a good idea that we do that. In this series, what I've actually done is used VMware Workstation to provide a virtualized environment to run vSphere and then run virtual machines inside those virtual machines. So it really comes down to a question of whether we should have a larger number of smaller servers or a small number of very large servers. And it really comes down to the number of physical servers that you already have in your environment, or the number of virtual machines anyway that you'd like to deploy. When we start talking about something like blade servers, where we have a high degree of physical consolidation of servers, that can be very good and provide us a very good way to consolidate large numbers of virtual machines into still a rather small physical footprint. Particularly in something like a virtual desktop infrastructure where we may have thousands of virtual machines running reasonably light workloads, that could work quite well. But as we saw, we have some pretty high capabilities for allocating hardware to virtual machines. So if we're talking about having virtual machines with 64 CPUs and 1 terabyte of memory, then we may be better reducing the number of servers that we have and consolidating onto those servers. And that's really what we want to try and do, is achieve the highest possible virtualization or consolidation ratio and get the highest number of virtual machines per physical host. Now, that could be 5 to 1 or 50 to 1 or 100 to 1, but it's really going to depend on the workloads that you're going to be running inside those virtual machines. If they're used primarily for compatibility of many, many different types of possible configurations, and those are used mostly for reference purposes or, occasional use for testing or debugging or troubleshooting, then our consolidation ratio is going to be much higher. For running high-scale production ERP type workloads or something along those lines, or decision support systems or any other type of, big data analytics or anything like that, then we're probably going to find that we're not able to get those aggressive types of ratios. But virtualization can still provide us with a benefit. We can more easily port virtualized environments from one physical environment to another. For example, moving from lab to production, or taking a copy of production and bringing it into lab to do tests with it, and so forth. So it's really going to be important that we try to understand and manage our workload patterns and identify which are the best candidates for virtualization, and then try to keep our project momentum going, and as we develop a more solid infrastructure for virtualization, to move more and more applications into it. But we're really going to have to think not only about the number of servers, but how we're going to integrate with our storage and our network. When we start consolidating 10 or 20 or 30 servers that previously were physical and had full access to resources such as network interfaces, and then we're going to want to try and share those, we might find that although we weren't necessarily using that much process or memory resources on our physical servers, that we're using a lot of storage, SAN fabric bandwidth or network fabric bandwidth. So what we're going to want to do is try to achieve the appropriate level of performance and availability, and that's potentially quite a lot of storage and network interfaces, and use tools like caching within the storage infrastructure, hardware offload, where we can do certain TCP/IP functions or Ethernet functions within our adapters rather than inside the operating system of ESXi, using things like NIC teaming or SAN multipathing, or techniques like trunking, for example, where we can attach our virtual switches to physical switches in the way we would typically attach physical switches to each other. That's going to help us potentially consolidate network links, or combine the capacity of multiple links, or keep different types of traffic segregated. Really the sort of things that we're going to talk about as we go through this whole series. So you really want to think about how much oversubscription you can really do. Our virtual machines can have multiple virtual processors, like I said, up to 64, but a single virtual processor really represents a single thread that would be executed on a physical core or a logical core for something like hyperthreading. So one virtual processor will never use more than one thread, therefore can never take advantage of more than one physical CPU. We can never provide the capacity of 4 physical CPUs to a virtual machine if that virtual machine only has one virtual CPU. So we're going to have to plan that, and we're going to have to be careful. Once we start oversubscribing processors, that can get much more difficult to manage, particularly where virtual machines have multiple virtual processors. So we'll want to keep that to a minimum, and we can actually allocate more virtual processors and more memory than the host contains but we're going to have to be careful about how we do that and whether it's appropriate to do that. We have quite a few techniques that we can use to guide the management of hardware resources within vSphere, things like resource pools and shares and reservations and the distributed resource scheduler, and we're going to talk about all of that later on in this video series. But it's still important to think about what's going on inside your guests and make sure that those applications are tuned appropriately, or that we use things like the Windows System Resource Manager or a resource manager in your other operating system, something like the NICE infrastructure within Linux, which we can use to allocate CPU and memory resources, because vSphere really doesn't have visibility into what's happening inside our guest virtual machines. So when we talk about vSphere, what we're really talking about is the ESXi hypervisor, or the old ESX hypervisor, combined with the vCenter or Virtual Center server. And vCenter provides the centralized management capability for multiple ESXi hosts. It handles authentication and security and integration with Active Directory, or integration with many directory services now using the single sign-on capabilities of vCenter 5.1, handles licensing, handles collecting performance and event statistics and alerts and scheduled tasks and so on, as we'll see in the later videos, and also enables things like the distributed resource scheduler and high availability clustering features like fault tolerance and distributed vSwitches and other things that not only require vCenter, but may require a particular edition of VMware. So refer to the documentation as to what all the different bundles and packages, and they've got a few different offerings for small business bundles for small numbers of servers, all the way up to Enterprise Plus for very large environments.